How do we know that the time machine was not invented? Did you know that when we look at the sky at night, we can see the past? Maybe the universe is only showing us what it wants us to know from the past. Maybe the stars we see now have died out millions of light years away or have lost their lives. It may be that the stars have been exhausted, their light has just reached us. Some stars change their brightness over time. Their brightness is usually very changes when you are young or very old. This is due to either expansion, contraction, or eruption, such as the internal dynamics of the star, or two or more stars' external dynamics caused by the eclipses they create while rotating in their orbits. Certain criteria have been determined in order to define a star as changing. Your star, the brightness and color change should be observable, detectable, on a time scale at the level of average human life. Many stars, including our Sun and the pole star, can be detected with sufficient sensitivity when measured. It is noticed that their brightness changes. The first variable star was discovered in 1639 by Johannes Holwerd's Omicron Ceti star found that its brightness changed over a period of 1 month. Classification of variable stars. Variable stars have been noticed and tried to be classified by scientists for a long time. According to the classification accepted today, there are basically two types of variable stars: internal changes, changes that occur with the physical processes taking place in the star. Pulsating variables are stars that show periodic expansion in their surface layers. Exploding variables, occasionally in the surface layers or in the depths of thermonuclear as a result of interactions. Very powerful explosions are seen from time to time. External changes. Changes that occur by physical processes occurring outside the star. Eclipsing binaries are binaries whose orbital planes are close to our line of sight. Its members, they regularly overlap. Whirling variables, in their light, are caused by dark or bright spots on their surfaces or each other, and there is a marked decrease in their apparent brightness. They show slight changes or ridge spots. Rotating stars are usually binary systems. Until now, many different classifications have been made according to the characteristics. However, the most important breakthrough was achieved at the meeting of the International Astronomical Union, IAU, in Hamburg in 1964. At the meeting, it was decided to gather the variable stars in three main classes. These three main classifications are pulsating variable stars, exploding variable stars, and eclipsing variable stars. It should be noted that these species also have many subclasses. Flickering variable stars. Surface layers refer to stars that contract and expand regularly. Vibration can be either diametrical, radial, or non-diametrical, non-radial. Diametrical ones always remain spherical. Sphericity is not maintained in non-diametrical ones, and adjacent regions on the star's surface move in opposite phases. Exploding variable stars. They are stars that show sudden explosions in their chromosphere and corona due to strong processes. The brightness change is usually accompanied by crustal events or outward flow of matter. The outward flow of matter can also be in the form of interaction with interstellar matter. Stars do not always shine at the same intensity in the sky. Some of them, which are called variable stars, show regular or irregular brightness changes. So, if our point of view is right, the dimmer one lowers the brightness as it passes in front of the other, and increases as it moves behind it. Covering variable stars. Occult variable stars are truly eclipsing binary stars and not occult, but they are double stars with distorted geometrical shape. Brightness change without covering them. They are also called ellipsoid variable stars, orbit of eclipsing binary. Stars' periods and the degree of regularity or disorder of stellar explosions are derived from the light curve. Can be found using further study of the light curve has led astronomers to allows them to calculate their mass or size. Decades of observation data reveals a period of change. It may even be a sign of the star's structural change. After what has been said so far, you can also make a variable star observation. You can ask, for this, you must first choose the variable star you will observe. Among the thousands of stars in the sky, you can choose a place according to your interest and observation possibilities. Choice must be made. Selection criteria for this. What time of year will you make your observation? This is whether the star you are observing is in the night sky at your location will show. How often will you make observations? Your observation frequency will determine the type of variable star you will observe. For example, the brightness make an observation once a month to observe. Long period, stars that change over long periods of time, data may be sufficient. What will you do with your observations? Some variables can be observed with the naked eye or with small binoculars, while others are dim. They can only be observed with a telescope. You will need to determine your goal according to your possibilities. For example, it is useful for those who want to observe with the naked eye to choose stars whose variation range is large enough to be noticed with the naked eye. Change more sensitive CCD imagers with telescope on stars with very low range can also be used. You can program your observations into AAVSO's database by editing them. You can send your data as placed in the database and on the variable you observe. All work done will be shown to you, so that your work can be combined with other work. You can also find the opportunity to examine how much they overlap here.